Hi, everyone. Welcome to day 2 of the Sustainability Challenge. My name is Kristina Bach. I'm the president and co-founder of Blue Ocean Sustainability, and I'm here to talk to you about the carbon calculation conundrum. When we think about the current carbon sort of process for how we calculate carbon, everyone tends to view carbon in these two buckets. There's the embodied carbon, which is all the carbon related to mainly the construction materials and how the building is put together. And then there's operational carbon related to what the building uses to actually operate. You know, what are we using to get it to the right temperature, maintain the right amount of ventilation, et cetera. And if we look specifically at the embodied carbon process, the way that that currently works is that we take environmental product declarations, or EPDs, which are a transparency document put out by manufacturers that go over the environmental impacts of their products, their specific materials. And we take those and feed those into some sort of life cycle analysis tool, an LCA tool, such as Building Transparency's EC3 tool, or Tally, or One-Click LCA. And those tools then will give us a result that shows the overall greenhouse gas impact for our building in metric tons of CO2 emissions. There's a couple different challenges with this approach that we're going to go over, but before we do, I just want to remind everyone what all is supposed to be in that definition of embodied carbon. So embodied carbon is supposed to be that carbon dioxide emissions associated with all the manufacturing, transportation, installation, maintenance, and disposal of building materials. Everything that goes into making the product, to you installing the product, to you using the product, and then how you're going to get rid of it at the end of its life. All of these stages, A through C, are supposed to be included. So the first challenge that we see with the current way that LCA analysis is done is that it's always based on either limited and or inconsistent input data. So when manufacturers are putting out an EPD for their materials, while they are supposed to be looking at all of these scopes, all these stages A through C, they're only required to include phases A1, A2, and A3, that material manufacturing carbon, in their EPD. They're not required to include any of the other phases. And the items in gray here that you'll see are basically never included. The items in light blue are sometimes included, sometimes not. And so what happens is some of your materials might have farther reaching stages. You might have some A4 and A5 assumptions for material. Some of them might only have those minimum requirement sort of items, the A1 through A3. So your calculation starts to get generated based on this sort of inconsistent data that's coming in, and it's not clear what you're always calculating. Additionally, while we know that the embodied carbon is supposed to have that transportation and installation, if they're only required to include A1 through A3, that EPD and that LCA is only really including the material carbon. It's just that manufacturing carbon. There's nothing else that goes into that projection. The other challenge that we see is that LCA analysis is frequently based on either the modeled quantities that are exactly in the Revit file. So if the building is showing that it needs 10,000 tons of concrete to stand up, that LCA analysis is only calculated based on 10,000 tons. Regardless of, let's say, the contractor might be ordering 10% of overage for, scrap, slump, et cetera. Or it's going to be based on the materials that are actually ordered. So if the contractor is ordering 11,000 tons, it's going to be calculating based on 11,000 tons. But in that case, it's missing, well, it's got the upfront carbon cost, what you spent to produce that material. It doesn't include any of the carbon related to the waste, because you're taking that, you're cutting off, let's say, 6 inches off of each of your panel, and that product is immediately going into the waste stream to get recycled, diverted, sent to landfill, et cetera. And as we know, there's a carbon impact for waste. However we get rid of it, there is additional carbon generated by sending something into the waste stream. So we have this sort of dichotomy of either tracking too much or too little and missing chunks and inconsistent input data into our basic tool of what goes into it. The second challenge that we see is that we're really asking the wrong party to track. We shouldn't be asking manufacturers to be tracking or trying to estimate anything related to the transportation to your job site or the on-site installation, A4 and A5. Because the reality is that's heavily dictated and driven by where your project is. If my project is in Minnesota, for example, and I'm buying a product that's from Michigan, my carbon footprint for my transportation sort of cost for that material is very different than if I was the exact same project, but based in California buying that same product. And there's not a good reason for why the manufacturer should be approximating or guesstimating sort of what that average might be. It's really something that we should be tracking at an end-to-end point to show our own footprint for our own projects. Additionally, contractors should really be tracking their own energy, water, and waste of their job sites, because those impacts will vary greatly based on their region and their installation methods. You know, if they're a contractor that has undergone the effort to move a lot of their equipment to electric-based equipment, they'll have a lower overall footprint, even for that material, than a contractor that might be using, you know, diesel equipment still for that same installation, that same product. And similar changes with in terms of if you're a contractor working in a location that has a really good sustainable sort of electrical grid, a large chunk of your power is coming from renewable sources, you'll have a lower carbon footprint than that same exact contractor in the same work, same amount of energy or electricity if they were in a space with a lower footprint grid. So it's really something that should be tracked at the job site level, not an estimation or an average based on kind of what's going on in the industry as a whole. The third issue that we see with this method is there's a duplication of data. So if the manufacturer has started to try to forecast and predict for their product what the use stage carbon is, how are we calculating and separating that out from the carbon impacts of the operations of our building? So if we think about, for example, a carpet manufacturer, if they were going to start looking at their use and maintenance, sort of, you know, all that carbon cost of their carpet, they're going to be looking at the carbon impacts of using and maintaining the carpet itself. So they're going to be saying, okay, well, we're recommending that they vacuum the carpet once a week. And we're going to, or once a day, excuse me, once a day. And we work 250 days a year, typically in the US, and multiply that by the average sort of energy, electricity use of an average vacuum cleaner. And then multiply that by the average carbon cost of a kilowatt of electricity in the US. And that's what we're going to put out there. And that's the assumption of kind of how much energy might be taken up by the use of that carpet and maintaining that carpet. The challenge is that vacuum cleaner is getting plugged into the main building, you know, outlet, their main meter. And so that electricity is also being counted from an operational standpoint if the building is using Energy Star Portfolio Manager or some other monitoring tool to track all of their energy usage. And what ends up happening is that we end up, you know, it's a worst case calculation, so that's good. We're overestimating what our carbon footprint might be, but we're double counting, and it really shouldn't be something that we're double counting. So really what we should be looking at is having anything related to use be tracked as its own sort of item, you know, it's included in that operational bucket. And from a material side, if you're doing replacements, if you're doing repairs, that all then carries all of that A1 through 3 production scope for the new carpet material. And you're going to want to track that disposal of that old material that you're replacing. And those are easy things to track at the building, you know, if you're going to do some replacements and repairs. So the final sort of big challenge that we see in terms of embodied carbon and how it's calculated currently is that the current process is it's a one-time calculation or report based on your initial design or construction. You know, it's taking that Revit file, it's taking your actual purchased items, it's running it through the LCA analysis sort of once, and then you're getting a total metric tons of CO2 emissions. It's very similar to kind of a driver's license. You take that test once, and other than maybe a small check to make sure you can still see with your eyes, most people don't have to retake that driving test to renew their license. The challenge is, as we know, buildings don't sit there in their base form forever. You know, they don't operate in that base form for 60 plus, 100 plus years of what their lifespan is. They're constantly sort of undergoing renovations, improvements, new systems, upgrades, etc. All these things that will change what that material footprint and use of that building is. So what we're proposing or suggesting is that the goal model should really be switching to a continuously evolving calculation of carbon impacts that includes all the design and operations from all the different phases. If you track a project through its construction and into its operation and continue to update that embodied carbon analysis for what materials you have added, what materials you've removed, etc., not only do you get that total metric tons of CO2 emissions, and can do the square foot analysis, you can also start doing analysis and comparisons based on your average metric tons of CO2 emissions per square foot per month. How do you compare to other buildings of similar type, similar age? How do you compare, different phases? What did I do in my construction phase versus this project did in a construction phase? If I'm a school with a concrete structure system, how do I compare to other like projects with similar structural systems? How am I faring? And you can actually look at that sort of analysis across phase. It's this idea that our carbon analysis moves from being a one and done sort of review to this continuous sort of odometer tracking log that just continues to tick up based on what's happening at the building, what changes are going on. And so this idea is really about how do we reboot the carbon calculation process? Instead of having this embodied carbon plus operational carbon sort of dichotomy, which we know isn't really accurate because the material carbon is missing that transportation and all the installation impacts, how do we move to something that shows that holistic, real picture? Embodied carbon as it's current calculated isn't really the full embodied carbon. It's much more that material carbon, just what's that material manufacturing piece. So our idea or concept is that really to reboot the carbon calculation, we need to start tracking all of the different carbon sort of projections and actuals based on all the phases of a building lifespan. We need to be doing that projection during the design phase, showing some forecast of what we think we're going to install, what we think it's going to use in operation. We need to track everything during the construction process so we know exactly what did our contractor actually buy, what did they use to install it, what were their emissions related to getting the building up and running and installed and in place. And then moving into this idea of, it continues to be an evolution where we track the operational carbon, but recognizing that that operational carbon is going to include the maintenance and some of that items related to those materials. And when we renovate, we track that renovation work in that scope of the operate. We track what materials we're removing, what materials we're replacing, what's the carbon impact of each of those items. And then finally, when we are removing any waste, whether it's the whole building gets demolished or as part of a renovation project, what are we removing? How are we tracking the waste and sort of related to that and what's happening with our carbon footprint from our waste stream? Recognizing that, as we've said, any site sort of waste has carbon impacts with it. It's not something that is just, as it leaves the site, it's fully done or fully reused. There are carbon costs for just getting it even off your job site. And so there's a lot of tools that have come out in the industry lately in terms of how do we track carbon analysis and move ourselves toward this full lifespan sort of a footprint. One of them being True Carbon, which is really focused on construction sites, tracking their process, what they actually use to get the building built, their energy, water, and waste impacts, to then let you add that in to what that LCA analysis shows for your A1 through 3 carbon, and what your operational tools, tracking tools such as Energy Star and other items show for your operational carbon, so that you can move to that full holistic footprint picture of how much carbon did you actually use in your building and how progressively is it sort of moving. Thanks so much.